Hello and welcome back. Alright, so the first general problem that we're going to take a look at is search. Now, there's a lot of ways that you can actually do a search, and it's going to depend on what your data set looks like. But let's start looking at how we search for items in a list type scenario or an array scenario. So if we go ahead and jump over into our whiteboard here, and we create an array of data, and we can just add some data in here. 0, 4, 6, 2, 1, 3. Let's have non-duplicates just for this example. And that's a 7. Alright, so now if the user asks you if there is a 2 in the data set, it's pretty easy to figure out how we're going to do this. We've already learned everything up to this point to actually solve this problem. What we can do is we can just iterate through our loop, or through our array, and we will jump down, and when we hit 2, we can return true as we found it, or we can return the index value in the array at which we found it. Whatever we're actually looking for our needs. Well, what happens if this array is sorted? So we have 0, 1, 2, 3, 4, 6, 7, and 9. Well, we could do the same thing. We could take an iterative approach, and we could walk down this array. And we can go 1, 2, 3, and again, we can return true, as yes, the number 2 is found, or we can return the index of, in this case, 2, and it can return the spot in the array. Well, what if your array is, let's say, 10,000 items? This iterative approach is going to work, but it's kind of slow. So the question is there a better way that we can do this? And the answer, of course, is yes. So if we look at our array, let's just look at it without the values in it. If we look at our array, we're going to have all these values within this array. Let's say there's ... some array with a bunch of values. Well, we can look at this as another strategy that we do. If you look up something in a phone book, if you've seen one of those in years, phone book, really huge stack of papers, or even a dictionary. A dictionary is better. In a dictionary, you're trying to find a word in the dictionary. Like, what is our general strategy that we're going to use? Well, in a dictionary, you can flip to the middle, and if the letter becomes before the word that you find on that page, you jump forward. So what this general strategy is called is kind of divide and conquer. So what we can do, is we can jump to the midpoint in our array. So let's say that's here, the midpoint. And then we can ask the question, greater than or less than? Which answer? Well, if it's less than, then we know it's got to be in this half of the array, and we can throw away the rest of the data over here. Well, if our number is greater than this midpoint value, well, then we know we need to look here. If it happens to equal our midpoint value, then hey, what do you know? We found it. We got lucky. And then we can continue that approach until we either find the answer or we run out of things to look for. And so this is also known as a binary search. So the implementation of this, you can do it in different ways. You can do an iterative approach, but that's actually a little more complicated to write the code for. What is more typically done is a method called a way to solve problems called recursion. Oops, that's a C. That's a U. Recursion. And so what recursion is really a methodology of using the same method over and over and over again, and it calls itself. So let's say you had a method called find. That's a curly brace. Well, you're going to have some code in here, and it's going to call itself again. And you may have some more code down here. And so right here, this, well, I don't know why I keep doing that. This is the recursive part of your program, where it actually calls itself multiple times. So now the important thing to do in recursion is to set up base cases. Because if you just had this method that called find and then called find, well, you'd end up with an exception during your program, which is going to be a Stack Overflow. But essentially what you have is an infinite loop. And that infinite loop is a very bad thing. So when we write recursive functions, we need to have a base case. And this base case is essentially just a terminator. It is a way for us to stop our recursion so that we don't get into these infinite loops. And then you typically just have the code. You may have multiple base cases depending on what your function is actually going to be. But in the majority of the cases, you're just going to have a base case, one or two statements, one or two conditions that you want to check, and then you're going to have the rest of your code that's going to implement your recursive method. It turns out that recursion actually has a lot of applications. Let's take a look at one of them real quick. So one common way that we can use recursion is to solve the factorial problem. So factorial is some number with the Bayes symbol. So what this does is it asks you to multiply this number all the way down to 1. So 4 times 3 times 2 times 1. And then you figure out what that is. So that's 12 times 2 is 24. So the generic way that you can write this is n factorial. So what this is that it's n times n minus 1 times n minus 2 all the way down to 1. Okay. So we learned that recursion is basically just calling itself. So what are our base cases in the factorial case? Well, there is 3 basic base cases, actually. The factorial needs to be positive. Has to be greater than or equal to 0 is the technical definition, because the factorial of 0, I believe, is 1. Factorial of 1 is also equal to 1. So, knowing that, let's go ahead and define what our function looks like. Okay, oops. Let's undo that. We need a return type, call int. We'll name our function factorial, and it will pass in integer parameter, call it n. That's a really bad n. We'll call it n. Okay, so let's do our first base case. Well, let's just go ahead and check. If n is less than 0, return negative 1. This is just a check. If you ever get negative 1 out of the factorial, you know, hey, something went wrong. Whatever. Alright, so if n equals 0, then return 1. If n equals 1, then we return 1. Is the factorial of 0 1, or is it 0? I actually don't recall at the moment. This may be wrong, so just heads up. but it's actually not important for the purposes uh, of this example here. So the next thing we need to do is we know that our definition looks like this: n times n minus 1 times n minus 2. Okay, well, we can do that. We can return n. Oh, well, actually, so what we should note is that this pattern repeats. So really, this is like n times n minus 1 factorial. Yeah, interesting. We can do this in our code, right? So what we need to do is return n times I guess we use x n times factorial of n minus 1. And so this little magic is actually going to compute the factorial for us. So we can go ahead and walk through an example. Let's see what happens when you pass in the value of 3 into our factorial. Okay, so what happens? Well, we get factorial 3, so n is not less than 0. We're good there. N is not equal to 0. N is not equal to 1. So then we return 3 times the factorial of 2. Okay, well, we can figure out what the factorial of 2 is. The factorial of 2 doesn't meet any of these conditions. So the factorial of 2 is actually equal to 2 times the factorial of 1. And we know what the factorial of 1 is. It actually hits one of our base cases, and so it just returns 1. Well, so what happens is that this right here gets replaced with 1 as it gets evaluated. And so our return statement returns 2 to this function call right here. And so now we have 3 times 2. And so at the end of it, our function stack unwinds, jumps up, jumps back out to the caller, and so we get a value of 6 that is returned based on this function call of the value of 3. So hope that made sense. Kind of a quick walkthrough of recursion. There's of course much more that you can learn about recursion, but that's really the basics of it. Is that you have your base cases right here, base cases, and then you have your actual recursive part, and it just calls itself. And so if you were to do factorial of n, obviously you're still going to end up in a, if you forgot the n minus 1 and you just put n, you're obviously going to run into an infinite loop here, because your base cases are never going to get hit because you're actually never decrementing your value. So it's important to realize that just because you have base cases, you're not actually guaranteed to not run into a infinite recursion state. But always note that if you don't have your base case, you are going to run into your infinite recursion problem. So we can use recursion to solve a lot of different problems like this. And in our next video, we're actually going to take a look at how we solve the search problem using similar recursion method that we just learned here. All right, thanks.